Good morning, everybody. I have examples here of polynomials where you're supposed to find zeros and factors of the polynomials. And you do this by synthetic division is one of the steps. So let's do a little review here. If I have a graph, and let's say it's crossing the x-axis at a couple of spots, like maybe right there, and we'll put another dot. Okay, so let's say the graph looks like that. It means it's crossing the x-axis at these three spots. Well, those 3 points are called x-intercepts. That's an x-intercept. And those are located on this graph at -3, +1, and +4. Well, another name for an x-intercept is a zero. And so the zeros of this graph are -3, 1, and 4, just those numbers. Now, if we were to turn those 3 numbers into factors, I would write x minus -3, x minus 1, and x minus 4. Because what we're doing really is working backwards. Think about x minus 1. If we are trying to find where that would equal 0, I would write x minus 1 equals 0, and then by solving, I would add 1 over, and I would get x equals +1. So whatever the 0 is, the factor, since it's always subtracting, it will be the opposite sign. So if the 0 is x equals 1, then the factor will be x minus 1. And I also, in the very first one, I wrote x minus -3, just so that you could see how it's always subtraction, but you could rewrite that as x plus 3, and then x minus 1, x minus 4. Okay, so just one quick way to remember, factors have parentheses and x in them, and then zeros are just the numbers. Okay, so in problem number 1, it's asking us to find all of the zeros. So usually these are the steps you go through. They have you make a list of all the possible rational zeros. Those would be the ones that are nice. Some teachers don't make you do this step, so if this doesn't sound familiar, then just completely skip it. But the way this works is the last number is called the P, and the very first number is called the Q, and you list out factors of P, like any number that divides evenly into P, which luckily it's just a 2, so that would be 1 and 2. Then you list out factors of the Q, and that's the number 3, so the only numbers that divide into 3 are 1 and 3. And then you take every P and divide by every Q. So I will get 1 divided by 1 and 1 divided by 3. Then I'll move on and I'll get 2 divided by 1 and 2 divided by 3. And let's just take a second to reduce those, and each one will also be plus or minus. So plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3. What this is a list of all of the possible rational zeros. So these are the possibilities. That doesn't mean they're all going to be zeros of the function. Now what the teachers usually let you do is take out your calculators and graph what the original function looks like, which I already did separately on my calculator, and this is what it looked like. It looked like this, and it had one there, and one there, and then it looked like that. So I could clearly see that it was crossing at 2, and that makes sense with our list of possibilities because 2 is one of them. And then I could also see that it was clearly crossing at -1, which almost also makes sense because see, -1 is on our list. And then you don't have to get all of the numbers from the graph, but I just wanted to show you that this final place where it's crossing right here is, all we know is that it's between 0 and -1. And it was a little closer to 0 than it was to -1. So this is the usefulness of our list. I can see in my list the only two fractions I have are -1/3 and -2/3, but it's not going to be -2/3 because it was a little bit closer to 0. So I actually know all of the zeros of this polynomial without even doing any work, but the teachers will not be happy with that. They want you to show the work behind it. So what we're going to do is just take only one of those zeros. So I'm going to unhighlight 2 of them. And how about if we stick with +2? Okay, so the number where it's crossing, I just moved a bunch of stuff out of our way. The 2, hopefully you've learned synthetic division. It goes in the outside part of synthetic division, and then we put the coefficients of our polynomial across here. So the number that you put out here, it has to be one of the zeros. So now in synthetic division, the 3 comes down, and then you multiply 3 times 2 is 6, and then you add. So that gets me 4. 4 times 2 is 8. I add those together, and I get 1. 1 times 2 is 2. I add those two numbers, and I get 0. All right, now, as soon as you do synthetic division and you have only 3 numbers right there, you rewrite your answer. We're going to have another example where we have to do synthetic division twice, so that's why I said that. So we rewrite this as it will become 3x squared plus 4x plus 1. And this 0 right here is what should have happened. That's the remainder. And if you've done it right, if 2 on the graph really was an x-intercept, the remainder should be 0 if you've done it right. And then the reason I know that this will be a squared power right there is that the original polynomial had a cubed power. So if I divide it once, then it takes that power down by 1 degree. Okay, now this is a quadratic. I have to think of some way to factor this. So I need something that will multiply to 3 and add up to 4, and this is just the way that all of my students do the factoring. They split the middle term. So this is going to be 3 and 1. So we usually go like this, 3x squared, and instead of 4x we write 3x plus 1x, and then plus the ending 1, and then we group the first 2 and last 2 things together, and we pull out the GCF from each of those. So that's like that. The second one, all we can do is take out a 1. And it's like that. And then this is what should have happened. Those are the same. I have a whole video on factoring that you can watch if this is confusing. But the blue ones go together. So I get 3x plus 1. And then the green ones we write down. X plus 1. And then the 2 that I used, I'll highlight that. Back up here, you also have to write the factor for that, which would be, we talked about this to the side, x minus 2. Okay, and then you set each one of these equal to 0, because those are your factors. But our answers will be when 3x plus 1 equals 0, x plus 1 equals 0. Some of this I'm sure you can do in your head. And when x minus 2 equals 0. So I get minus 1, and I'll have to also divide by 3. So I do get x equals -1/3. That's one of my answers. And then this one, x equals -1, And this one, we already knew this one because we saw it on the graph. Actually, we saw all three on the graph. X equals 2. So that's all of the work that you can show behind when you look at the graph. Remember, here's our graph. I moved it around, but it was crossing at those three spots that I'm just now highlighting. And those are the same as these three answers, -1/3, -1, and 2. And so those are the final answers to this question. Now on this page, I have another one. Find all zeros, both real and imaginary. This is x to the 4th power. I'm going to skip the list this time. We will just make ourselves a graph on our calculator and find we will need 2 numbers where it's crossing, because since this is to the 4th power, we have to do synthetic division twice. Now I just graphed that on my calculator, and this is what I found. That it looks like this. This is just a rough sketch of it. Oops. Well, it's hitting at 1 and at -2. And there's no other places where I can see it hitting. That tells me ahead of time that there's going to be 2 imaginary zeros, because there always has to be the same amount as the degree, which is 4. So there has to be 4 zeros altogether. But what we're going to do is take either one of those numbers, let's say -2, and we're going to do synthetic division on our original equation. So I'm just copying down the coefficients, and then I'll do the synthetic division. So the 1 comes down, I multiply 1 times -2, and then I add, multiply -7 times -2, and then I add 2 plus 14, 16 times -2, and then I add, so that's -10. -10 times -2 is 20, and this is what should have happened. My remainder is 0, which is very good. Now, on the other problem, I started writing like x cubed minus 7x squared plus 16x minus 10. I'm not going to do that here. I'm going to erase that. Don't be tempted to write in the x's yet, because we still have to divide once more, because our goal is to get it down to a quadratic, because quadratics are much easier to work with. So +1 was the other place on the graph where it was crossing, so now I'll do division with that. So I have 1, 1, -6, -6, 10, 10, 0. And this is my remainder. So again, good. It came out to 0. Now I can rewrite my answer with the x's put back in. It has become x squared minus 6x plus 10. The reason that it is x squared is because the original was x to the 4th, and I divided twice, so it depresses it down to x squared. So now, let's write all of our factors so far. We have this quadratic one, x squared minus 6x plus 10. And then the ones that I did in the division were x, it was -2, so I write x plus 2. And +1 means the factor is x minus 1. Okay, so now I would try to factor this, x squared minus 6x plus 10. But there's nothing that multiplies to 10 and adds up to 6, so it's not factorable. But that doesn't mean I get to just skip everything to do with that. The question asked us for all of the zeros, both real and imaginary. So since it doesn't factor, use the quadratic formula instead. You can always use the quadratic formula, but if things factor, it's usually easier to do factoring. All right, so x squared minus 6x plus 10. So I will do -b, which is 6, plus or minus the square root, b squared, so -6 squared, minus 4 times a times c, all over 2a. So I will simplify this. 6 plus or minus, and this is going to be 36 minus 40, which is negative 4, all over 2. All right, and then the square root of negative 4, because of the negative, you can write an I, and the square root of 4 is a nice number, which is just 2, so put the 2 in front of the I. It looks better that way. And then all of it divided by 2, and then just go ahead and divide each thing on top by 2. So that gives us 3 plus or minus I. Those are two answers because of the plus and minus, and they're imaginary. So we can start to make a list of our zeros. We have, let's write them separately just so you can see how they're two separate answers. 3 plus I and 3 minus I are two of our zeros. And then from x plus 2, we would get negative 2. And from x minus 1, we would get positive 1. And that right there is our list of the zeros. There's 4 of them, which makes sense because the degree of our original was 4. And that's it.